management, but this topic sort of merges the two together, and it's about how AI and what I'm going to define as intelligent automation are shaping, changing and shaping knowledge work. Okay, so there should be plenty of time for discussion. I aim to speak no more than 40 minutes, maybe 45 minutes. There should be 10, 15, maybe more time for conversation. I'm happy to share the slides with anyone after. There's a full set of references on the last slide, so anything I refer to here you can find from the reference list. My email and Twitter is there. If anybody wants to contact me, feel free to follow me on Twitter. My Twitter account is a holistic account, so it's me as a human being. So it's partly about work, but it's also partly about other things like dogs and football and politics in Scotland. So if you follow me on Twitter, you get all the random stuff in my life as well as my work stuff. But feel free to follow me if you're interested. So what I'm going to do today is I'm going to start defining some concepts, because I think talking about AI, it's necessary to give a definition, and then I'll define intelligent automation, a concept that Crispin Coombs and myself and a couple of others developed. Then I'm going to start by looking at the sort of general impact of AI technologies on work and society, and there's a bit of a debate about their impact, and it's emerging. So I'm deliberately going to present sort of contrasting perspectives on that. Then I'm going to focus specifically on sort of knowledge work or professional work, and look at the application of AI technologies and what we call intelligent automation to this specific type of work. So the central focus is on knowledge work or professional work and how AI technologies are impacting on that. Okay, and in terms of that impact, I'm going to make a distinction between what's currently happening with knowledge work, and what's currently happening is the automation of routine elements of professional work or knowledge work. But I want to speculate that there may be potential to achieve the full automation of all knowledge work. So even the creative aspects of knowledge work potentially could be automated. But again, I want to suggest this is a debate, and there's competing perspectives here. And you may, I'm going to sort of sit in the fence a bit, and you may say that makes me cowardly, but I would genuinely say that the future of work, because of AI, is uncertain. We're at a period now where change is emerging. So anybody, I would say, who gives you certain statements about what the future will be are speculating. No matter how certain they seem, they're speculating, I would argue, because we don't quite know. Things are very embryonic and very emergent. So I think it's useful at this point to maybe acknowledge the lack of consensus and present different perspectives. So that's, I am unashamedly sort of sitting on the fence and presenting alternative views. Okay, and if you want to push me on where my particular preferences are, you can ask me questions later on. So artificial intelligence, what am I talking about? So in terms of technology, this is broad and heterogeneous, but fundamentally the core thing about AI is these are technologies which can match human cognitive capabilities. They can learn and adapt and evolve. They can mimic the kind of human brain and cognition. So these are not static technologies. They evolve and learn and adapt and improve independently of human beings designing them. So AI technology is something which you can design it, and then it will independently develop and improve. So in terms of technologies, this might include things like algorithms, machine learning, big data, so computer programs, software you can define as AI, natural language processing systems. The next slide I'm going to talk a bit more about this. Some of the technological developments mean that we have technologies which sound and sometimes look like human beings. And this is part of the innovation in these technologies, and natural language processing technologies have evolved enormously in the last 10 years. And it also includes advanced and mobile robotics. So it sometimes includes sort of humanoid type robots, or a physical embodiment of a technology which has some AI capabilities built in. Okay. And if you want to come back to this later, that's fine. So in terms of looking and sounding human, my slides got slightly distorted and loading up here. So what I want to suggest is, one aspect of these developments is that these technologies sound and possibly look more human. So in terms of sounding human, we're much closer to that. So if you think of Alexa and chatbots for call centres, increasingly they sound very human. And as I say, natural language processing technologies have evolved enormously. And you can talk to chatbots and some of these technologies, and some people are fooled because their adaptability is so good. They almost sound human, and they're getting much better at understanding people with different accents and coping with different accents. I know people in Yorkshire speak funny, and even Alexa and these technologies are getting better at coping with Yorkshire and Scottish accents. I've got a PhD student who's looking at AI implementation in a local council, and they're actually programming it to understand the Aberdonian dialect. So you can program chatbots to be very sensitive to kind of dialects and language. I've put an arrow to suggest they might be becoming more physically human. At the moment, we don't have, I would say, realistic humanoid robots, but that's maybe something that might happen in the future. The Blade Runner vision of replicants which look human is, I would say, somewhere in the distant future. But we're closer to that than we have been. But we have chatbots which sound very human. Okay. So intelligent automation. So this was a term that Crispin, myself, and Sarah and Stanimira. I'll explain my collaborators in a minute, but we were developing a paper which was published in JSIS, and we were trying to come up with a concept. The reviewers didn't like some of the phrasing and concepts we had, so we were trying to come up with a concept to describe things. So we came up with this idea of intelligent automation. Okay, so this is the use of AI technology in work to automate tasks. Okay, but I would say this is distinct from traditional automation, which is maybe factory based. So traditional automation is about automating manual tasks, production lines to produce cars or computers or televisions, etc. So you can automate production lines to physically manufacture goods. What we're talking about is distinct from that. We're talking about automation of knowledge work, of office work, of professional work. So intelligent automation is distinct in that sense, but it's also distinct in terms of the ability to learn and adapt. So traditional automation, robots in factories, they don't learn and adapt and evolve independently. They maybe change when you redesign them, but a factory robot is very efficient at doing certain tasks, and that's all it can do. Whereas intelligent automation is AI systems which can learn and adapt and improve. Okay, so these are two quite significant distinctions from traditional automation. So we use the concept intelligent automation to talk about the automation of sort of creative work. Okay. So stepping back from intelligent automation, just to put a bit of context, because there's a lot of debate on these issues, but different perspectives on, the impact of AI on work, society, economy in general. Before getting into that, just a quick acknowledgement. This presentation and the papers is a collaboration with 3 other people: Crispin Coombs, Stanimira Taneva, Sarah Barnard. We were all at Loughborough at the time, Stanimira is now at Nottingham, but Crispin and Sarah are both still at Loughborough. There's a list of publications we've produced at the end if you want to look at that. A lot of the analysis here is based on a literature review we did, which has been published in JSIS. So we did a review of academic literature looking at the implementation of AI in work. We did a systematic review of academic databases between 2011, 2017. That identified 1,500 sources. We then filtered it down to 184, which was our final sample. If you want more details on the methodology and how we found the items and how we filtered them, those details are in the paper. So this analysis is based on that sample of 184 journal articles and conference papers. Okay. So the ambiguous or uncertain impact of AI on society. So, I'm unashamedly fence sitting, and I would say I'm doing the same as Stephen Hawking. This quote here was a lecture he did in 2017. Cambridge set up a research centre into AI, and this is one little quote where he says, "Powerful AI could prove to be either the best or the worst thing ever to happen to humanity. It's too early to tell." Now, I would say that's a perfect example of fence sitting, and I'm not meaning that in a negative way. Worst or best, and I think there's a strong degree of truth to that because we don't quite know. We're in the process of developing, implementing, using these technologies, and I would say it is too early to tell definitively what their long-term impact is going to be. So to frame this idea of different perspectives, I'm using the idea of a framework developed by Makridakis, and he identified 4 different perspectives on AI: optimist, pessimist, pragmatist, and doubters. And you can play a really interesting game where you try and categorize yourself according to these labels. So the optimist is where people have a sort of utopian view that robots, human beings will be in charge of society, and we can design robots to do all the jobs. And all we need to do as a human race is focus on leisure and creativity and being happy and all these sorts of things. The optimist vision fits with Daniel Bell's kind of 1970s vision of post-industrial information society, where we can automate all tasks. Okay, so that's a very positive vision where robots do all the work and we're in control. The pessimist vision is similarly positive about technological developments, but it's much more of a sort of negative, pessimistic vision where we design robots so powerful that they eventually take over, and we become second-class citizens, and we have intelligent robots which evolve to be much more intelligent than we are. So this fits much more with the sort of dystopian science fiction films that Arnold Schwarzenegger's in. I'm struggling to remember the names. Terminator. This is a Terminator type vision where robots have taken over. The pragmatist vision assumes there'll be a happy balance where human beings will still do work. We're not going to be purely focused on leisure, but there's going to be this balance where we work collaboratively with robots. So we can get robots to do all the stuff we don't want, and we can do all the nice, interesting bits of work, and we can design AI to augment work, and we will collaborate with AI. The doubters take, I would say, an extreme position on intelligence, and they would say that human intelligence is an absolutely unique thing. As beings, our intelligence is what makes us unique in the animal race, and we can't program computers, no matter how complex or powerful or advanced. We can't program computers to replicate human creative work. Okay, the doubters would say, there's something unique and distinctive about intelligence, and we just can't program that into a computer. Okay, so a brief sample of how these perspectives have shaped debate about society in general. So the pessimist perspective So there's sort of two exemplars here, Frey and Osborne, who published some very influential work, and they did an analysis which suggests that almost 50% of jobs in the USA can be eliminated through automation. The Bank of England used that analysis and made similar predictions that in the UK, 15 million jobs, which is about half of the UK workforce, could be susceptible to automation. And the book on the right, Martin Ford's book, he's a journalist. It's a very sort of negative book about the rise of the robots, and if you follow him on Twitter, it's a very pessimistic thing because he's constantly tweeting about where robots have replaced human beings in jobs. But there is an alternative perspective, the sort of optimist, pragmatist perspective, and this perspective is adopted by a wide range of organisations. So there's been a number of reports about AI over recent years. So the TUC, PricewaterhouseCoopers, McKinsey have all produced reports on this. Matthew Taylor produced a government report about the future of work, which I'm going to refer to in a minute. And all of these reports are much more optimistic. They actually say that GDP might go up if we, as a country, if the UK invests appropriately in these technologies, we may benefit from appropriate investment. And this analysis says predictions of mass unemployment is exaggerated because what might happen is the automation of tasks, but not the automation of complete jobs. And I'm going to elaborate on this. So as an example, the Taylor report said that maybe 10% of jobs might be susceptible to complete automation. Okay, so much more modest job losses. But these reports also suggest there's multiple employment trends going on simultaneously. So there may be some job losses with highly repetitive roles. Routine admin work may be completely automated. There's going to be some degree of job augmentation where people and robots collaborate, and I'm going to develop this more in a few slides. And finally, there may also be new jobs and new industries and new sectors, because if we're developing AI technologies, we need people to design, manufacture, service, repair these products. Okay, and that might create whole new industries and levels of employment, etc. Okay. So I now want to focus on intelligent automation and job augmentation, and specifically in the context of knowledge work. So I want to start by looking at what automation has been done already in knowledge work, okay? And then towards the end, I want to speculate about future trends, okay, potential future trends. So I want to start here by looking at what aspects of knowledge work have already been automated, okay? So augmentation, I've used this concept a number of times. So this is basically where humans and robots or AI technologies collaborate together. And currently, AI systems and robots have been designed to do routine tasks, and human beings still typically underdo the complex tasks, the non-routine things, ad hoc decision making, creative tasks, etc. Okay, so a number of jobs people have to use AI systems, but it's typically routine elements, and I'm going to give some examples of this. Okay. Before getting into that, I want to just link to definitions of knowledge work so that we can sort of embed in that literature. So definitions of knowledge work, the classic definition is knowledge work is intellectual, creative, non-routine, and it involves utilizing or creating knowledge. So typical exemplars would be traditional professions like doctors and lawyers and architects, but it also includes more contemporary jobs such as consultants, software designers, etc. Okay, so the scope for automation, I think, becomes clearer when you link to Mats Alveson's work. I'm a big fan of Mats Alveson's analysis because he takes a sort of critical perspective to a lot of things, and he's published a lot of work on knowledge work and knowledge intensive firms, and he takes a sort of critical perspective, and he suggests that with with knowledge work, if you take these traditional definitions, he suggests there's a number of ambiguities about knowledge work. Firstly, there's ambiguities about the type of knowledge workers use. Secondly, there's ambiguities about how much the work of knowledge workers is actually creative and intellectual. Maybe there's aspects of knowledge work which are quite routine. Okay, and the final ambiguity is about the extent to which knowledge work contributes to organisational performance. There's a big rhetoric which suggests knowledge workers are the key source of competitive advantage, and he suggests that we need to maybe question that. But of these three ambiguities, it's the middle one, it's the second one, which is relevant for automation. And Alvison basically says, you can look at any knowledge work, and it's not all about creativity, it's not all about problem solving. Knowledge workers sometimes have to do routine, repetitive tasks. And that's the aspect of knowledge work which is currently open to automation. Okay, so I'm going to give some examples of that. So these are all examples taken from our literature review. So I'm going to give three examples. There's references for each, and the references can be found in our papers at the end. So one example is healthcare, and this is with using robots, humanoid type robots with children with autism, and this is where, and there's been found to be benefits of using robots in this context. Children with autism seem to find these robots more predictable to deal with and less stressful and less challenging. So the healthcare professional will be in a separate room, and they'll be controlling the robot, and they'll be talking through the robot. So the robot is controlled and manipulated by the healthcare professional. And they will analyse the behaviour, and they will communicate to the autistic children through that. So this is a classic example of augmentation where humans and AI and robots are working collaboratively. This is not about replacing the healthcare worker. To some extent, the healthcare worker might even be upskilled because they're having to use the technology, and it's changing the nature of their jobs. So some other examples. So this is, three jobs where routine admin work. Okay, a lot of professional work involves some element of routine admin. So there's three examples here: auditing, pathology, financial services. And machine learning and algorithms are being used in all of these jobs. And there's case studies that we've made reference to. So there's jobs and companies which are using AI, currently to do parts of these jobs. So in terms of auditing, one aspect of auditing work is analysing data sets of clients, looking at, financial data over a period of years, and AI systems have been used to help analyse all this financial data of auditing clients. Pathology, AI has been used for analysing digital images and scans. There's been publicity in the last couple of years about AI analysing breast cancer scans, and there was some research which suggests that AI was more accurate at analysing breast cancer mastectomy scans than human consultants. Okay, and financial services, AI has been used to analyse data on market trends and make recommendations for financial investments. So with all of these jobs, human workers still fundamentally make decisions. The AI systems analyse the data, the algorithms churn the data, etc. But fundamentally, you still have a human worker making the decisions, taking responsibility, etc., doing the creative work. But in all of these jobs, some element of the routine part has been automated. Final example is robot-assisted surgery. And there's two very well-established systems, Da Vinci and Rosa. These are, I can't tell you exactly when they were implemented, but these are well-established robotic surgical systems. They have a whole number of they're used for a wide range of surgical applications. They have a whole number of benefits that they can reduce the intrusion of surgery, and because of that, significantly improve people's recovery time. But in terms of augmentation, the key thing is this is not about replacing human surgeons. The human surgeon is in control. They use and manipulate the robot to achieve their task. So effectively, the robot is a tool being used by the surgeon. The robot doesn't act independently. The robot is controlled and manipulated. So it's just another tool, but a very sophisticated tool used by the surgeons. Okay. So all the examples so far have been about automation of the routine aspects of knowledge work. Now, what I want to speculate on is, can we go a step beyond this and automate all knowledge work and the sort of creative aspects of knowledge work? Okay. So, and I want to come back to the sort of optimist pessimist framework to do this. Okay, because in terms of considering this possible future, there is again debate. Okay, so there is some analysis which says, and I would say both optimist and pessimist views, which suggest that this might well be possible. Okay, I've put a screenshot of the Susskind and Susskind book. That's probably about 4 or 5 years old now, about the future of the professions, but they're very concerned, I would say, about how AI and technology might transform professional work. So there are a number of writers and analysts who suggest that the automation of creative work, the automation of decision making, may well be something which is very likely to happen soon. Okay, and to give an example of speculation in this domain, this is one paper that was published. The reference is at the bottom. So this is a paper published in 2008. This was an analysis of AI academics. It was a survey of AI academics. So this is speculation. And this was a survey of AI academics, asking them how they envisioned the future of work and various jobs. Okay, so this is speculation by AI academics. And they suggest that AI might take over a whole number of tasks, such as language translation, which we're probably most of the way there, driving, automated driving, and a lot of these technologies are highly advanced. Working in retail, so the full automation of retail work, writing best-selling books, complete automation of surgery, etc. So this is highly speculative, but this is the optimism of AI researchers, and there's some speculation that within 50 years there could be significant advances. A footnote: Asian AI academics are more optimistic about these developments happening quicker rather than American academics. So predictions vary if you look at kind of geographic differences. Okay, so there is speculation that within 10, 20, 30 years we may be able to automate creative work and fully automate knowledge work. Okay, but to come back to the sort of contrasting perspective framework, there are doubters who would say that automating creative work is maybe not feasible. Coming back to this definition of cognition and the human brain as unique, the doubters still argue that the brain is an organic, dynamic, evolving, complex system, something that evolves from birth. And really, we don't fully understand, even with advances in neuroscience, etc., we don't fully understand, if you take an adult human being, we don't fully understand intelligence and how it evolves from birth, and how it's shaped by context, etc. But the doubters would say, this uncertainty means that human creativity can never be programmed, can never be automated. And it is useful to acknowledge that despite advances in neuroscience, etc., there is not a consensus about the nature of human intelligence. even now. There's a lot of uncertainty, debate, controversy about intelligence. Okay, so I can give a definition of AI, but to be honest, if you talk to neuroscientists and cognitive scientists, there's a debate about I, let alone AI. Okay, and the final retort of the doubters would be that they. Wait a minute, sorry. The doubters would look at this type of analysis and say that's just overly optimistic. Okay, you can speculate, but that's unrealistic speculation. And there's lots of predictions of future developments which have often proved exaggerated and inaccurate. Okay, so just because you can find AI scientists who say this is going to happen, it doesn't mean it will happen. That's speculation. That's optimism. Okay, so the future of knowledge work and how it's going to be changed by these technologies, I would say, is open to debate. Okay, so there we go. I've stopped. That's me finished. So hopefully you found that stimulating. I'll pass back to Frank to chair the discussion whichever way you want. I'm happy to answer questions and respond to questions and discuss things as much as you want.